everybody, today we're going to look at Cartesian products with real-life examples. We'll also look at an example using set builder notation to make sure you're ready for the problems that you'll see in your homework. So let's start off with what is a Cartesian product. A Cartesian product pairs every element in one set with every element in another set. But it's important that when it makes the Cartesian product, it is giving order to the set, so it matters which one goes first and which one goes second. In real-world systems, we see this happen when lists of data are combined. Let's use an onboarding example to see what that looks like. Let's say we have a set of employees. We're going to call that set E, and it consists of 3 elements, Jordan, Taylor, and Casey. Then we're going to have a set of tasks. We're going to name the set of tasks T, and that's going to include HR paperwork, security training, and benefits enrollment. When we make the Cartesian product of E times T, we're going to pair each person with each of the 3 tasks that need to be completed. So Jordan will have paperwork, Jordan will have security training, Jordan will have benefits enrollment. Taylor will also have HR paperwork, security training, and benefits enrollment. And Casey will have HR paperwork, security training, and benefits enrollment. So when we count the results, you can see that the number of employees was 3, the number of tasks was 3, and our total combinations is 3 times 3, which is 9. Remember, each pair represents 1 employee completing 1 task. So what happens if we add more tasks? Let's say our new task set is HR paperwork, security training, benefits enrollment, email setup, employee badge, and parking assignments. So now with our 3 employees and our 6 tasks, we would have 3 times 6, which is 18 total combinations. We're not going to bother to write those out right now, but you do see that as we add more employees or more tasks, the number of combinations is going to grow really quickly. So if you're asking why this matters, it's because databases and programs often combine lists of data. So just like our employees and tasks, it could be users and products, customers and orders. These combinations are all things we can write using Cartesian products. Let's do a problem where we practice doing a Cartesian product using set builder notation. So my set A is the set of all x, where I'm given that x is an integer. I also know that x squared needs to be less than 20 and x has to be even. B is a set of all y is a natural number, and y is a factor of 12. Let's start by deciding which of these pairs of numbers would be in the Cartesian product of a times b. Let's start with negative 2, 3. Negative 2 is even. When I square negative 2, I get 4, so that says negative 2 is an a. 3 is a factor of 12, so that number is in B, so negative 2, 3 would be in my Cartesian product. Next we have 6, 2. Well, 6 is even, but 6 squared is 36. Because 36 is bigger than 20, we know 6 is not in A, so we can cross out this pair 6, 2. How about 0, 4? 0 is even, 0 squared is 0, that's less than 20, so 0 is in A. 4 is a factor of 12, so we know 4 is in B, so that says 0, 4 is part of our Cartesian product. How about 2, 5? Well, 2 is even, 2 squared is 4, less than 20, but 5 is not a factor of 12, so we can cross 2, 5 out. And then our last one, I have negative 4, 12. Well, negative 4 again is even. Negative 4 squared is 16, that's great, it's less than 20. That says negative 4 is an A. 12 is a factor of itself, so negative 4, 12 is also an ordered pair that belongs to A times B. So let's keep our sets A and B, and this time let's find the number of elements that will be in the Cartesian product. Again, we're not going to write them out, but we are going to figure out how big A times B is going to be, which means how many ordered pairs would I have if I did write them out. It might help if we write the elements of A. So A is negative 4, negative 2, 0, 2, and 4, is the even integers whose square is less than 20. Then when we look at B, the factors of 12, that are natural numbers, we'll have 1, 2, 3, 4, 6, and 12. A has 5 elements, B has 6 elements. That says the Cartesian product of A times B would have 30 elements.